Hi, good morning.
Hi, Don.
Hi.
Are you excited for the last day of class?
A little bit, yeah.
Yep. No more math finance for you after today.
Guess so, yeah.
No more EO's formula.
I've gotten pretty used to it at this point.
Yeah. And the good news is probably on the interview, they won't ask you on EO's formula. They may ask you on other things, but okay. I guess we'll just give it 1 or 2 more minutes for folks to sign in. Okay. I guess we can start. So last time, the big topic or the main idea, okay, of last time's discussion is about the idea of a change of numeraire. The idea of numeraire, right, and the idea of change of numeraire. Okay. So first of all, what is a numeraire and what's the context of numeraire? So you want to remember the following, right? So the context is that, well, you don't have to, but preferably we would start with some kind of basic risk neutral probability. Could be the domestic risk neutral probability, for example. Start with a risk neutral probability. P tilde. Okay. So this is where we kind of, sort of the given, okay, starting point that we always start. But within, right, this framework, we have, several assets. One of them is something we call, N, okay? There's an NT process that satisfies, I'm going to write this. I'm not sure I introduced it last time, but this notation, DT, D for discount. DT-NT is a P tilde martingale, okay? DT is the discounting process. The reason I write it like this is because I want you to kind of get used to what, we only have one class left. But the idea is, after this section, we're going to talk about stochastic interest rate models. So we're going to go to a setting where, interest rate is no longer a constant. So, preparing, right, a more general framework where we do not assume the interest rate is a constant is helpful, to make connection. But if you want, you can still think of it like this. E to minus RT and T is a martingale. And that's fine, for understanding numeraire. But So basically, it must be a fair price process. All right. Then we can use NT as a denominator. Okay, denomination. If NT is a fair price process like this, okay, so I guess the verbally NT is a fair price process. I'm not sure the word fair price process is universal, is probably my invention, but it really means, as I explained, that a one share in the future is worth exactly whatever one share is worth today, right? It doesn't lose value. Anyway, if it's something like this, then we can use it as denomination. In other words, anything else, any other value process, okay, any other value process, you can denominate, right, other value process v, right, in the denomination of n, right, and by dividing and then just denote like that. Okay, so that's definition, right? Pretty straightforward. But then, right, so you want to ask, right, questions. So what questions should you ask about? So this whole process, right, of course, is called change of numeraire. So the first, I guess, most important question for us is, how does pricing work? So, pricing works at two levels. One is the abstract level, where you connect, the future to the present with a conditional expectation. Okay, that's the abstract framework. And the other, right, is a more formulaic framework where you ask, okay, with that connection, how do I write down, right, a computation, a formula? So when I say how does pricing work, what I mean is more like the abstract framework, okay, under the change of numeraire. So with the new numeraire, I guess. So here, there is, so together with introducing a numeraire, right, so the answer is, first of all, we have a new measure, right? We have a new probability associated with the numeraire itself. Okay. And basically, it's a change of measure kernel. In other words, the new one, right, is the old one. So the probability of something is the expectation under the old one on that set, right? But do this. Okay. So in other words, DT/NT here, right, is required to be a martingale. And we divide by N0 to make sure that it has expectation 1, right? So DT/NT over N0 here exactly plays a role of ZT in the change of measure kernel before. All right. So we just defined something like this. Then the point is this, that we have two results, okay? So basically, sort of like you have a new point of view under this new change of measure kernel. So under this new point of view, right? Okay, so you can introduce any change of measure you want, as long as it satisfies certain rule, like this guy is non-negative and expectation is 1, it's a martingale, etc. But the relevant question to ask is, what's the effect? Okay. What do we get under this new measure? Okay. So the effect, first of all, the effect is very intuitive like this. If V, right, if V, the discounted process, is a martingale before, meaning it's a fair price process, right? Again, you know, it's fine to work under the martingale, to think under the martingale framework. But if you want to connect it to pricing, it just really means, right? So the discounting just really means point back to the present. So it's a fair price process under the old framework. Then under the new framework, under the new denomination, is also a fair price process. All right. So it's a bit interesting like this. All right. And this is the way it's always stated. But I always find it funny that somehow there's a, you know, discounting here and there's no discounting here. All right. So that's not a mistake. It's exactly like this. But actually, well, I guess the first question of the day, do you kind of see why there's no discounting when we look at the, you know, the new one under the new numeraire? There's no discounting remaining, right? Which obviously leads to the pricing equation like this. Okay. So why is there no discounting? And what do you think the benefit is for having it like that? Can anyone guess? Right, remember, the definition is very intuitive. You just denominate, right, the all value process under the units of n. Question is, why is it that when you do that, right? And the old statement is you must discount, right? Discounting bring you back to present. Why don't you have discount under the new numeraire?
Has it already been discounted in a way?
Yeah, why so, Sherry? Exactly, but why? That's exactly the beauty of it, but why?
I guess just by the, like when we divide by n, for example, then that just discounts it already.
Yes and no, right? You're almost there. Well, n is n, right? N doesn't have to have a discount in it, but except, right, that the reason is because, you know, it doesn't hurt if you divide it like this, right? So you can include a discounting factor in there too. Does it make sense? And in fact, right, possibly the definition should be like this. Why? Because we insist that, you know, the discounting process is a martingale, right? The process itself is not a martingale, but, you know, like somehow we, in our daily life, we're so used to thinking of the stock price rather than a discounted stock price. So, you know, stating it like this is more natural, right? But mathematically, actually, that's what's happening. Okay, and then actually even pushing further, right? As I mentioned before, I said that this can be viewed as measuring n under a numeraire, right? Because dt, what is dt? dt is always connected with another process called mt, where m, right, is the value of the money market account. Right? M tracks the value of the $1 starting at time 0 and grows to time little t. So usually, right, MT would be just e to r times little t if our interest rate is a constant. But in general, again, right, saving account, you can have a floating rate, right? So it will just change from day to day. So in general, this guy is a stochastic process. Okay, if we want to kind of really capture like the most general setup. So whatever this guy is, but discounting, right, from that moment back to the present is just dividing by the worth, right, of the 1 unit of of the money market account. What that really means, right, is that DTNT, right, is just NT dividing by MT, right? So exactly in this way. In other words, you are measuring the asset under the unit of the money market account. Okay, so you can think of actually P tilde is already a change of numeraire, right? So the point of view is actually you start from P, the physical probability, where absolutely there's no numeraire. But because it's no numeraire, that there's no fair price process under the physical measure, right? But from P, then you change to P tilde by introducing your very first numeraire, which is the money market account. And then from there, right, you can branch onto other choices of numeraire, right? But because of that, already in effect, right, the discounting factor is taken, into the formula in the new numeraire. So what's the advantage of this? Do you see? What's the advantage of not having the discount factor in the new setup? I guess this is this advantage you probably won't appreciate by now, but I'm just guessing if you see the advantage. The advantage, as I said, you probably won't see it. You don't see it until now. Is there's no need to model the discounting process, or by that, equivalently, or the interest rate itself. So, when you do pricing of options, which, is what we've been doing so far, because the main focus is on the stock, right? Letting the interest rate to be constant or not doesn't really hurt, I guess. But when it comes to fixed income, right? When you model the bond itself, because, you want to capture the behavior of the bond, using the interest rate as a constant process is nonsense, right? So in that setup, so let me show you, right? And we're gonna hopefully try to discuss a little bit of that today. Is, for example, you have a bond like this. Okay, big T is the maturity, right? The time is the mature time. So in other words, basically we're saying that at time big T, the bond value is 1. Okay, so of course the question is, what is the, what is BT T like this? Well, so normally, right, you would do something like this. You would say, well, it is this, right? That's acceptable, I guess, in the stock pricing, in the option pricing setup. When the focus on the bond itself, then that, like I said, is too simplistic, right? So what we would say is that it's going to be the discounting from time t to time big T of RUDU condition on FT, where R itself is a stochastic process. Okay, so I hope, right, you see that this is intuitive. Basically, you're just adding, right, interest rate from time little t to time big T. This is how much, I guess the money account accumulate, right? During that time interval, you divide by it by, taking negative exponential. And that, because b big T is 1, right? That's kind of like the imaginary multiplied by 1 there. We get the price of the bond at time little t. Except you see that, right? Trying to calculate this guy out is no joke. Why? Because this is a stochastic process. You're going to integrate it. Remember, the whole point of the Asian option is we don't have the analytic formula for it, right? Why? Because the integral, right, as innocent as it is, having a distribution for it is not easy, right? So there, right, you kind of encountering the Asian option again in some way, except that you don't even have an exponential, right? So this is the right formulation. You just have to respect that. But pricing it, right, in terms of coming out with a formula, it's not easy. Well, we're going to work with this formulation anyway. But what I'm trying to say is, suppose that one can find some other numeraire where this doesn't happen, okay? And even, like this is the bond, even with like option pricing now, right? If you work in a stochastic interest rate setup, then the discounting process will be like this, okay? Like if you want to price V0, for example, an option, let's say just American, let's just say, a call option, then this will be your pricing formula. All right. And then this is no joke, really, because this is stochastic, so you cannot bring it out, right? You have to keep it in. So you have two sources of randomness, one from the interest rate, one from the stock. They may even be connected, right? They may be correlated, right? Forget your Black-Scholes, right? I mean, like, you'll be lucky if you can even get some numerical approximation here. So you see that this is the pricing under the risk-neutral probability. If somehow you can find another numeraire, right, like this, then, okay, you see, so this is basically Vn, right, because I divide by n big T. But the point is that this guy disappears. Okay, this guy disappeared. This is exactly writing this down at time 0. Okay, this guy disappears. And even more magically, suppose somehow that nt is equal to 1. Okay, is that too good to ask for? Maybe, maybe not. But suppose that you have something like that, then eventually you say that under the new numeraire, this is your pricing formula. Can you believe that? Just like your good old Black-Scholes, right? Except that now, well, let's not get too excited. This is now the stock price under the new framework, right? Every time you change measure, you have to look at the new dynamics. But at least, right, the gain, right, seems to be that the interest rate got, basically you absorb the interest rate into the numeraire, I guess, as Cherry said. So, you don't have to deal with it directly. Is that okay? That's a big advantage, actually. Any question on this? So let me ask you this, right? So see if you follow. I hope you see that, these derivations are correct according to the change of numeraire framework. The only maybe magic thing I pull is that, actually from here to here, there's no surprise, right? It doesn't seem like a gain because instead of dealing with this, you have to deal with division by n big T, right? Which, because n is a numeraire, right? Potentially nt is also a stochastic process. So there's no gain there really. But I say that magically somehow I can choose, right, a numeraire such that nt equals to 1, right? Then that really simplifies. Is there anything like that? that I can use, or it's just my invention, right? That's just wishful thinking. There's no such thing like that, right? There's nothing that as good as that. Or is there? Is there any way we can go from here to here with a legit choice of numeraire? Anyone? Do you know any price process that at their expiration, they are guaranteed to end up at 1? So let me ask you this, right? Just in case, because again, if you're new to this, you don't know how to think. Can I just use the cash? Right? I mean, $1 right now, right, will end up as $1 in the future, right? So can I just use the cash process? In other words, NT is identically 1. That sounds very weird, right? I mean, but can I just use the cash as a numeraire? Right? I'm asking for something such that n big T equals to 1. So yeah, why not just use the cash? Why do I make a big deal out of it? Can I?
I guess so, since it's still doable.
What is the number one requirement for something to be a numeraire? What is the number one requirement for something to qualify as a numeraire?
Mhm.
The number one requirement is a fair price process. Okay.
The price process needs to be a martingale.
Yeah, or just to speak in layman's term, one share in the future must be worth like 1 share today.
Okay.
Is $1 in the future worth the same as $1 today?
Mhm.
Is $1 in the future worth the same as $1 today?
Maybe not.
No, right? The whole point of currency is to lose values because time value of money. So exactly, right? The constant choice is not a legal choice to be a numeraire to begin with. Is that okay? So I just want to, I think I mentioned this before, but I want to mention again that cash, okay, currency by itself, whether foreign currency or domestic currency, is not a choice to be a numeraire. The money market account is, all right, the saving account is. In other words, right, NT to be E to RT, if R is constant, or you just write like this. If R is stochastic, right, which by the way is the money market account, that is a valid choice. But exactly because you have the growth in interest rate at time big T, it cannot be 1. Okay, you follow? So again, right, is there anything, right, that is a fair price process? Okay, or if you prefer to think in terms of martingale, is discounted price is a martingale, yet it ends up at 1 at time big T. All right, let me save the suspense. It's exactly this guy right here, the bond. Okay, the bond is, right, a fair price process because 1 share of the bond in the future as long as you don't go beyond, right, expiration, I guess, is exactly worth one share of the bond today. Do you agree? The pricing equation says so too. So the bond is exactly that numeraire, right? So BTT satisfies the discounted bond price is a martingale if you really want to go with the martingale setup, or I just prefer to say, right, the bond price is a fair price process. Then, and also by definition, at maturity, it will converge to 1, right, the face value. Therefore, in this formulation, to avoid dealing with interest rate itself, we can use a change of numeraire. So V, we call it VT. Okay, like this. Sure, right? Like I said, I mean, again, I don't want to kind of make it sound like I'm, pushing you guys to something different, but I feel like it's very beneficial for you to not just stay with the math in this class, even though, I'm a math person. I want you to get the financial sense of things. So when you say NT, right, equals to 1 for all T, what product are you referring to? Right? Or when I say NT equals to 1, right, what am I referring to? What product? The answer, I hope, right, is clear, is cash. You mean the $1 bill, right? $1 bill is always worth $1 at any time. Do you agree? But then you want to check whether it fits the description of a numeraire. And as I explained to Don, right, that numeraire can be very general. The only restriction we want is that basically, intuitively it's quite clear. You want to use it as a, a measurement, right, as a unit of denomination. You probably prefer it to be a fair price process itself. In other words, right, is value, right? The discounted value is a martingale or it's a fair price process. But the cash exactly doesn't satisfy that because cash is loose value, right? One currency in the future, right? $1 bill 50 years from now cannot be worth the same as $1 right now. I guess that fact is obvious. Yep, right. So now, actually, I was about to comment on that here, but then I kind of, start to discuss other stuff. This sort of is a little bit counterintuitive, or let me just say counter habit. Right, we always like to think, okay, how much is this worth in euro? You just take whatever the exchange rate, right, and divide. In other words, we have this habit where, I mean, not habit, it's very natural for us, right? If QT is the exchange rate, then we like to do this, right? We like to do VT over QT, right? As the the currency, right, in the euro or yuan, whatever your other foreign currency is. Except you see that doing this is fine. This is conversion into the foreign currency at that time, except that this is not change of numeraire. Okay, because you forgot the discounting factor on the sorry, I guess up here, right? You forgot the discounting factor under the foreign currency, right? Or if you want, you must divide by the foreign money market account in order, right? Or I guess we sometimes use the NFT to make it into a legit change of numeraire. Is that okay? this is exactly the factor that always trip us up. It makes sense to talk of just conversion, right? We do that all the time, except that mathematically or pricing wise, right? This is not a legit object in terms of change of numeraire. Is that okay? I hope that's not too confusing to separate. Or in other words, QT itself is not a numeraire. Why? Because QT is a currency, right? And QT is just a €1 bill, for example, €1 bill. But €1 bill, right, exactly suffers the same, right, issue as the dollar bill, right? That in the future it will lose value. So therefore, right, even though conveniently this is what we do, it's not changing number. Are we okay with this? All right. So now going back to this new fancy thing I'm trying to introduce you, that in the setup where interest rate, okay, is not constant, stochastic, then if you use the numeraire that is the bond, then in terms of pricing, something beautiful happened, right? In terms of pricing, let me write down here. Okay, so this is just some, diversion. Okay, so if we define the change of numeraire using, the bond price itself, then under this conversion, it works like this. Whoops. Yeah, it works like that. And more particularly, at time big T, because BTT is 1, right? When you divide at time big T, this is just become V big T. Is that okay? And this is very, very common or very popular, so that people give it a name. All right, people call this measure is called the forward measure. I guess if you want to make sure that you know what expiration you're using, you say forward T measure. Okay. Any question on this? So we'll go back to this right soon, but let me maybe press one more thing, right? Connecting financially. Do you know what this action does, or does it have any financial sense? Like, when you do this, right? If you just don't look at the foreign discount, then this is just basically converting, right? Domestic currency to foreign currency, right? So this is a very meaningful act financially. What about this? Does it have any meaning? Or we just mathematically divide, right? As I say, like, you want to make sure that when you write down the math, you can see the meaning behind it. It'll make your guide, it will guide your action further. When we do this, does it have any meaning? Okay. So maybe, right, to do that, let us tell a story that of a product that we haven't mentioned in this class for a long time, the Ford contract. Okay. So let's revisit the Ford contract. A Ford contract with strike K on some asset with expiration big T. So we write it like this, right? Question: what is the price of this Ford contract? Now, I think, right, first of all, you should always know this. But second, I want to add one extra requirement. We require that you look at the general framework. That is, I want you to not assume constant interest rate. Okay. I mean, if you want, you can give me the answer when the interest rate is constant. That's okay. Then we'll look at it. But the real point of me asking you this question is I want you to see if you know the answer to this when the interest rate is not constant. Anyone? What's the price of a Ford contract? Ah, very good, Kashif, except you got the discount on the wrong place. Very good. It's the other way. It's this. Okay. Now, in case you get confused, right? How do you know which one is which? Well, actually, you can always cheat, right? And pull out your pricing equation, no? Because, right, VT, I said, right, you should kind of not always try to make sense of things, but a lot of times you can just rely on the math too. Is this, right? Well, then is this. So here I did use the fact, right, that R is not a you know, R is a constant, so I did not obey this, right? But that's fine for now. Oh, sorry, right? But then exactly because this is a martingale, is this. Okay. So that's why we get this. So what if R is not a constant? How do I modify this formula? Well, so first, maybe you're not used to this formulation, but let's just do it. Is this. Okay. Then here I can only factor out a K because K is constant. Notice, right? However fancy you want to write this, this is still a discounting factor, right? This is still a discounting factor. So this is a discounting factor. Therefore, this would still be S little t. Okay. Except that, what is this then? Right. So this is S little t because S is a fair price process. So whether interest rate is constant or not, right? Discounting stock price is still martingale. Is that okay? So here I get this. What about this? What is the last factor here? How do I price it when interest rate is not constant? Well, it's our new friend, the bond price, right? Because this is exactly just pricing $1 at time little t. So in other words, the answer here is the most general answer you can give is this. And why do we say it's the most general formula? The reason is, you know, this little r is artificial, right? We all know that little r is not really constant. So when you write this formula down, it's a little bit not precise. But when you write like this, it's precise because anyone, right? We can all go look up the current stock price. We can also go and look up the current bond price with that expiration. So everything here is precise. Of course, I also cheat a little bit. All right. This guy may not be looked up precisely if the expiration does not line up with whatever products, right, the market is offering. Because, for example, this is like some weird odd time remaining, like 28 days, right? The market may have bond price that has 30 days remaining, but they don't have any 28 days remaining bond for you to look up. So you have to do some interpolation. That's besides the fact. But the point is, right, this is just some product that can potentially be traded on the market and you can look up, right? So there's no assumption here at all. So everything here is in terms of market price. Is that okay? So that's the forward contract. Now, there's some very special forward contract, right, called the forward price. I mean, not forward price, but the question that you always ask with a forward contract is, at what value of K is VT equal to 0? All right. At what value of K, and maybe let me say this, right? K here will be a function of T and big T, right? At what value of K at time little t with reference to expiration big T is the forward contract price 0 there. By the way, right, 0 is a very special number in finance because that means it's free, right? Free to enter, free to exit. So 0 is a good reference point for many things. So for answer, well, look at this, right? Look at this. This is a forward price at any time little t. You know what K, you want to know what K it is? Well, just solve for it. So VT is S little t minus K bond TT. You want it to be 0, right? Okay, then K is okay. And actually, right, it's actually not called K anymore. It's called F, right? F for forward. Okay. So you see that quantity, right? Do you remember what this guy is? That's how change in numeraire. So, right, I'm not sure I give you a lot of information already, but this change in numeraire, right, is such that when you do pricing, the interest rate disappears, right? So it's good by itself. But then more importantly, we discover that this act is a very natural act, okay, in the market. It basically converts a value process into its forward price. It converts a value process into its forward price. Yeah, Kashif, is a good question, right? It's a good question. So conceptually, it's slightly different. It's still a strike though. But when you say K fixed, your point of view is that you're looking at the entire process from, so as T changes from. So if you fix a strike, right, the contract price will change, right, as time changes, right? Because I mean, clearly, this is the price, right? So it's like you're chasing, you're tracking one single contract from time zero to time to maturity, which is, of course, I admit, the most natural point of view. Or, you know, when you hear of a contract, that's what you think of. But that's not, you know, sophisticated financial thinking. The financial thinking is, you know, at any time t, right? So in other words, at any time t, I want to know that very special strike so that V under that strike is always zero. Do you understand? So this point of view is like I fix the contract price at all the time. I want all the time the contract price zero. Then clearly what must change? The strike. So it's clearly I'm not looking at the same contract at all as from time zero time big T. I'm looking at different contracts. All right. But that is not even relevant there. The relevance is what is it I'm looking at really? I'm looking at the future price or the forward price of the stock. Okay. And I did mention the word future. I think the word futures is used more often in finance than forward. But right, you heard of, I'm sure you heard of future price of corn, futures price of oil, that kind of thing, right? So basically what does futures mean? Futures just means that exactly that price you can lock at that time for a future delivery of that asset for free. I mean, for free means not like you can get that asset for free in the future, but you can lock in that price in the future and it doesn't cost you anything to lock in that price. Yeah. You know, like I said, you know, Kashif, I want to buy a corn from you, right? I don't know, let's lock in the price. Let's say, I don't know, you know, 10 cents per bushel, right? But to be delivered 3 months from now. Okay, so 10 cents per bushel is the forward price, right? It's a futures price that I'm locking with you. You may charge me a fee for that, right? If the lock-in price is too low or too high, who knows? But if we lock in it just right, then you and I don't have to exchange any money. Okay, and that right is exactly right, reflecting the future value of the corn from our current point of view. Yeah. Okay. Yeah. Very, very popular thing to do in finance. I mean, futures is traded all the time, right? There's a whole trading floor, right? Devoted to it, right? Is it the CBOT or something from Chicago? Anyway, right? where were we? So what I'm saying, right, is that, right, this act of conversion, even though we look at from the change of numeraire point of view, is a very, very real financial process. It's just converting a process, a price process, into its futures value, right, or forward value. Are we okay here? So let's not lose sense of, you know, the real gain, the real loss, whatever. What I'm saying is, right, so maybe here's the message, and here's what makes change of numeraire fascinating, but also maybe confusing, right, to the newcomers. So message is that there is great flexibility in choosing numeraire. Okay, you can choose almost anything you want. Again, as long as, right, the numeraire itself is a fair price process. Okay, so of course the next question is, okay, so what do I choose? The answer is I don't know. You know, I cannot tell you. The only thing I can tell you is, right, you want to choose the one that's most natural for your application, right? You should choose the one that's most natural for the current work. Okay, I'm not saying much here, right? Because what does the most natural mean? Well, that implies that you have to be a little bit experienced, right? But you know, well, experience only comes with, you know, time. But anyway, I think that you can still get some sense of what most natural mean. You see two examples actually, all right, throughout the lecture. One example, right, is this, that suppose that, you know, QT is the exchange rate, right? So this is the strike, sorry, this is the call option, right, on the foreign currency. Then most natural is P tilde, is the domestic currency, right? The point of view of the domestic currency. If you look at, let's say, a put on the dollar, right? So notice this is the put on the dollar. Okay. So this is in the foreign currency, okay? The unit of this and this are different. The unit of this and this are different. Then the most natural one is P tilde F, or P tilde NF. Finally, if you have, whoops, the usual call option, for example, but your interest rate is no longer constant, then the most natural one is the forward measure. Okay. So, all right. So what is most natural in this setup? I guess, you know, to be blunt, they all kind of got driven by by Black-Scholes formula in some way. As you see that we try to kind of force the framework a little bit, right? Not too much. It's still natural, but we try to kind of gear it so that we can get a pricing formula out using Black-Scholes formula, right? So you will see that all of these we try, but so the point of view is we pick the most natural framework, and then we try to say that in that most natural framework we can apply Black-Scholes formula. All right. But so anyway, right, I still would argue, right, that it feels right that domestic currency use domestic risk neutral probability, foreign currency use foreign risk neutral probability, stochastic interest rate use forward or futures price. Notice, right, futures price sort of implicitly say that interest rate is taken into account. Do you agree? Right, back to the example that I try to lock in, right, a corn price with Kashif, right? The fact that I lock in the price with him for the futures, that should mean that somehow interest rate, right, is taken into account in a magical manner for sure, but right, in some way, right? Actually, it's not too magical because you see the bond price, right? The bond price is used, right, to do that conversion. But the bond price, right, exactly is how you pull, right, the future to the present. Yes, the bond price is how you translate $1 in the future into the present, right? So the bond price actually is a locking mechanism, right? The bond price is a way for you to lock in a payment in the future that's worth exactly $1. Okay, so that's not too surprising that when you want to lock in the interest rate, you don't want to deal with interest rate. You use the bond as a mechanism. Any question? Okay. So I was explaining to you what kind of questions you should ask, and I did not even get to the second question yet. This is just the first question, right? How does pricing work? But there's even another question is this, and that actually goes with the second one. Question number 4, how do we compute pricing under P tilde N? So, right, remember, abstractly, change of numeraire only says this. Abstractly, this is all it says. Okay. Now, you know, concretely, you may want to look at these things, for example, right? So, for example, concretely, it says that, right? So let me say this. Concretely, for example, suppose that you have VF is KF minus 1 over QT. All right. So concretely, well, so first of all, right, as we mentioned before, the translating this abstract formula into this framework means that this will be this. Whoops. Like that. All right. So in other words, I just have to use a foreign risk neutral probability. I have to discount under the foreign rate, but then I have that, right? So when I say concretely here, I haven't been concrete yet, okay? This is still abstract. But how to make this concrete? How to make this concrete is, I guess, like I did ask you, right, on the homework of this week even, exactly is how to make this into a Black-Scholes, right? In other words, I want something like, you know, roughly speaking, right? Expect something like, is it something like this? You know, honestly, I forgot the put formula already for Black-Scholes, but is this something like K and D something, right? Something I forgot is minus or plus, probably minus or something. But you know, something like that, right? I mean the put formula, but this is my expectation. Meaning, right? I want to when we say compute, right, that's what we want. Is that okay? We want that. But before, right, we can make our wish come true, what do we need? Right? What do we need to translate this to this? What we need is how to describe 1 over qt under p tilde f, right? Because Black-Scholes exactly works under, right, the dynamics R sigma, yeah, right? You got to give Black-Scholes R and sigma, then Black-Scholes will tell you, right, this is ND plus, ND minus, etc., etc. So if you don't know what R and sigma is, right, I guess here you know R is RF. I guess that comes for free. What's sigma, right? What's the volatility? And again, right, if you want a blunt message, right, I mean, I don't like it to be too simplistic, but I guess one question, and maybe it's not that simplistic either, what is the volatility of 1 over qt under E tilde f? Okay. Or, you know, because, right, volatility is all that matters in terms of option pricing. Like, for example, you know, like just to bring this home, right? And then there are many layers to this. But what I want to say is this, right? Suppose you have a stock, right? So another question, not connected with, sort of connected with this, but not the same question, is this. Suppose I have a stock, okay? ST has volatility sigma under P tilde. Does ST have volatility sigma under P tilde F? Or, right, this is probably nonsense. I have to convert, right? So does ST over QT have volatility sigma under P tilde F? You follow? Right? I have an asset, right? It has some kind of volatility under the domestic currency. I convert it to the foreign currency. Right, and I want to do some option pricing with it, let's say. And I guess you're knowledgeable, right, with Black-Scholes now. You know that only volatility matters. Okay, can I use? Is it the volatility before? From you understand the relevance of the question? So is it the same volatility? So, right, by the way, the real question is this, right? The dynamics, right, under the new probability, because that's what you use to price. But if you want to make it a little bit more intuitive and simplistic, do things retain volatility, right, when you do conversion? Like this. Well, the answer is should not be. I mean, you know, there's, without doing, you know, concrete calculation, it's hard to say a hard yes or hard no, but the answer is should not be. Why not? Why not is because, you know, when you do conversion like this, right, there are two things that enter. The stock itself, right, has some volatility. By the way, right, volatility is just basically, right, the rate of the variance, right, of the returns. So it kind of measures how fluctuation, right, the stock is. But QT, right, the exchange rate itself is also stochastic. Qt also has its own volatility, right? So when you convert like this, you see that you kind of combine the two sources of volatility, right? You have the stock itself and you have the exchange rate itself. So you don't expect that when you combine like this, the volatility level stays the same. You understand? So at least intuitively, that should not be. So that you have your work cut out for you like that already. Like to basically investigate, right? So roughly speaking, right, the main question is to investigate DSNT under P tilde N if we are given DST P tilde. This is the main goal. Okay. After you get this, then you can answer the question of concrete calculation. Because concrete calculation is kind of, right, is about that. It's about understanding the new dynamics, understanding how, you know, the asset behaves under the new lens. Okay, so you need to understand that. Is that okay? That's the goal. That's the last goal. Question on this. So let me pull up my notes a little bit. All right, so what's the result here, right? What can we say in this setup? So the result is this. Give me a moment. All right. So let me give you the abstract result, okay? And then I'll tell you concretely how to apply it to our model. So the abstract result is like this. The abstract result, right? So you need to follow in the following schemes. So first, remember, so once upon a time, we mentioned a change of measure kernel, right? Materials. And it's roughly something like this. Suppose that you find a new measure, right? I forgot what we call it at that time. Actually, we call it, I think we go from P to P tilde, right? So let's say, suppose we have something like this and start from, you know, the physical one, something like this, right? That's what we did. And then we had something like this, right? That basically ZT, right, is e to the minus theta t minus 1/2 theta square times, sorry, e to the minus 1/2 theta square times t minus theta times wt. Okay. If we have this, then w tilde t equals to wt plus theta times t is a p tilde Brine motion. Okay. So the message is basically change of measure is roughly equivalent to change of drift. In the brine motion. In other words, if you want to keep track, okay, if you want to keep track of the effect of the change of measure kernel, all you need to do is to kind of keep track of what the effect is on the brine motion in terms of drift. Okay, so you just need to keep track of what happens on the brine motion in terms of change of drift. So now applying to our framework, right? Apply to our framework. In our change of numeraire framework. Whoops. We have a new numeraire, which is our E tilde, right? Like this. And let's do this, right? dt nt over n0. Okay. So we set up condition so that this is also a martingale, blah, blah, blah. So let's just call it z, okay? Also z, but zn, meaning like an exponential martingale, but coming from the n terms. So what we have, right? Because this guy is also a martingale, we have that this also follow a structure like this. Let me write it, okay? And then I'll explain. Okay. So this basically describes the martingale structure of dt and t. All right. So don't worry about too much. The point is, if you want, you can think of this as the theta right there. This right here has the same structure as the theta, except that, you know, there are two generalizations. The first is I allow this to be dependent on time. Won't happen too much, okay, in this section. But the second actually is more important, right? What is up with this notation, etc. What is up with this notation is that here, the brine motion can be multidimensional. So this notation allows you to have more than one brine motion. All right. If you remember, right, for example, right, in our framework, dqt, right, was r minus rf qt dt plus sigma 2 times rho dw tilde 1 plus square root of 1 minus rho square dw tilde 2. Okay. So because of this, our for money market account is r qt dt plus, oh sorry, right, I missed qt, sigma nft rho dw tilde 1t 1 minus rho square dw tilde 2t. Okay. So the z, right, the z process describes the discounted price of the foreign money market. So Z and FT, right, is e to the minus 1/2 what? So here, right, maybe let me write that the other one first, that mysterious object for you. The new process of 2u of t will be a vector of sigma 2 times rho and sigma 2 times square root of 1 minus rho square. That's the process, okay? Because you see that it's the one that basically got associated with the Brownian motion. So it's kind of your volatility term, right? It is your volatility term, but it has two components, right? You see this and this. Is that okay? So your ZNF will be e to the minus 1/2 sigma 2 square times t, all right, plus sigma 2 rho w1 t tilde plus sigma 2 square root, so I can put out the sigma 2 plus square root of 1 minus rho square dw tilde 2. Is that okay? Trust me, eventually the result will be quite simple, but I just want to kind of make sure you understand the notation in terms of, you know, the connection, because the point is this. You see up here, this theta will be the one that gets plugged in, right, into the new Brownian motion, right? The theta, the new theta is the ones that get plugged into the new Brownian motion. So therefore, right, these guys right here will be the ones that get plugged into the new Brownian motion W tilde F. Is that okay? Any question? I think I introduced a lot of symbols here. So any questions before we continue? All right. So in our change of numeraire framework, okay, we assume that our numeraire has this structure. That's what we mean here. So this is exactly the martingale structure of our numeraire. It's like this. If that is true, then the result is the new Brownian motion. Okay, so main result is the new Brownian motion will be our old Brownian motion minus this. Okay, so that, if you will, right, this is how we chase, whoops. This is how we chase the drift from the risk neutral probability to the new, okay, to the new setup. So in other words, what I'm saying is then if this is my concrete model in terms of foreign exchange, then W tilde F1 will be W tilde 1 minus sigma 2 times rho times T. W tilde F2 will be W tilde 2 minus sigma 2 square root 1 minus rho squared times t. Okay. Any question on this? Okay. So far, right, 1 just reminds you of the old fact. 2 tells you the effect of a change of drift. 3 will be how it affects our stock. Okay. So the idea is this, that basically, right? So remember that Sn, right, is St over Nt. We know is a martingale under P tilde n, right? So you know that when you look at dsnt, right, it must have no drift. It only has the by motion term. Well, the question is, what is this in front? All right. Well, you have originally, let's say st, right? dst is rst dt, let's say, plus sigma st dw tilde t. Okay, sigma, let's say sigma 1. And then the numerator is sigma 2. You know, just like this, right? Oh, sorry, this is NF. Just like this, right? Except that you see, this is the whole big brine motion there. Anyway, the point is, right, when you divide, you expect that this becomes a minus, right? You expect that this becomes a minus. And indeed it is. All right. That will be under the new probability. So, right, the message for you is the following. Under the new probability, right, under the new probability, the new brine motion is the old brine motion, subtracting the drift, right? Subtracting that volatility. So this is V, right, is the volatility term of N. All right. In terms of change of volatility, the new numerator, right, the stock, the denominator in the numerator is the old volatility, right? This is old vol of S, and then this is the vol of N. So in other words, right, the volatility of the numeraire, right, gets subtracted from the volatility of the original stock. And if you want the intuition, right, this is because it's dividing. You should, right, justify this more rigorously using Ito's formula. So it is shown to you in the notes, and I think in the homework, right, you're asked to do it with D of 1 over QT. Right, and there I expect you to do the calculation. But if you except when I ask you to do it explicitly, you can just use this abstract result and just do it very quickly to get the dynamics under the new numeraire. Again, right, I do know that I'm telling you a lot of new things. Any question before we look at the example for the foreign exchange? Question? Okay, so let's concretely look at the foreign exchange, right? Suppose that the foreign exchange model is this, right? DST is RSTDT plus sigma 1, right? STDW tilde 1. The NFT is R NFTDT plus sigma 2 rho DW tilde 1 plus square root of 1 minus rho square DW tilde 2. What is this under the new probability? What are the terms? If you can apply this result, then you know what we are doing. Right? What is this? What is this? This is the abstract result for you. How does it work out in this concrete model? It will be like that. Is that okay? Notice, right? This is new Brownian motion, not the old one. So there's an F here. F standing for the Brownian motion under the NF measure, right? It's not the old one under the P tilde. This is Brownian motion under the foreign exchange, under foreign currency probability. How do I get that? Because I get this minus this. And then how do I get the second term? The second term basically, right, is because 0, right? Okay. So because it's 0, you got only this. So right, again, notice this is like a multi-dimensional result, right? When we say this, we do allow for this to be vectors. So it's entry by entry, right? You subtract. Is it okay? So maybe to test your understanding, let me ask you this. What about this? If I just divide by the foreign exchange, what is it? How is this different from this? Absolutely does. And I think you're getting to something, Cherry, but I'm not sure what you mean by different R's. We do, right? Because RF and R, are different, right? One is foreign exchange risk-free, one is foreign currency risk-free rate, one is domestic risk-free rate. But I'm not sure what you're getting at concretely. You're getting to a right area, but what are you saying? So what is the difference between NF and Q, right? By the way, a lot of these are just notations, all right? I mean, there's nothing really deep here. It's probably my notation, which I don't invent it, by the way. This is like the book's notation. But, if you don't understand what they mean and you don't connect them, you cannot connect them. It just becomes that much more difficult, right? But what do I mean by this and what do I mean by this? This is the foreign exchange rate, meaning the value of the foreign currency. This is the foreign money market account, right? Meaning the foreign currency deposited, right, to the foreign saving account. So the relationship between this and this is something like this. Right? So in other words, this is the discounted version of this. In other words, this is an undiscounted version. So it will be that. By that, I mean, I hope you understand what I mean. This whole thing goes into here. Okay or no okay? Right? At this level, we must be able to do this kind of quick calculation very quickly. If we just really differentiate and apply Ito's formula everywhere we go, it's just too much work, right? You quickly realize that this is the non-discounted version of that. So obviously it just picks up an extra interest rate term. So let's push it a little further. Well, this then. Can you go there? Well, let's compare this and this, right? So how is 1 different from S? Well, 1 is different from S in 2 ways, right? S has sigma 1, right? So 1 is obviously cache, I guess, right? S has sigma 1. Cache has no sigma 1. So the sigma 1 should be 0. Second, right, cache has no interest rate. So that doesn't mean interest rate is 0 here because interest rate doesn't show up, right? But what that means is that there's a discounting factor or something like that to compensate for the fact that S is absent. So in other words, right, for the second term, it will be 1 over QT times minus rho sigma 2 minus square root of 1 minus rho square. Or let me do this. Times dw tilde 2f. Okay. So this is like this, right? Except sigma 1 is equal to 0 because, you know, that, like that. What about this term? Well, clearly there's no S. But more than that, the absence of F, S, make it like this. So that is the answer that, you know, I was looking for, I guess, on the homework. But even further, right, I would like you to derive this more rigorously through Ito's formula, not through guessing, right? Here I told you how to guess, right, based on what you know. So you know sequentially you go like this, right, from here to here to here. Just kind of deducing what should happen going downward. But on the homework, I would like you to, you know, because basically, right, from the homework, the point of view of the homework is like this. You know what QT is, right? You know what QT is in terms of something like this, right? And then plus sigma 2 times something, right? You know that. And so therefore, you know what 1 over QT is. Okay. But notice that whatever dot dot here is going to be dw tilde 1 and dw tilde 2, right? So then you can convert this, if you want, at this stage into dw tilde 1f and dw tilde 2f. How do you convert it? By using the conversion that you are given in the homework, or exactly this conversion right here. Okay. And then your final task is then to do this, apply Ito's formula. But you should discover that if you plug in the conversion, somehow everything cancels out and you get that. Is that okay? So that's what the approach of the homework is. But if you use the approach of the homework, then everything is rigorous. There's no guessing, right? Here I'm guessing that this is this, this is this. Homework, you just do pure calculation, right? Taking this conversion as a given. Any question? All right. So that this conversion should take care of all you need to do for foreign currency, right? Probably. Because like I said, fundamentally, if you know how to go from one Brown motion to the other, the rest you can figure out, at worst by Ito's formula. But you should also try to make use of this kind of nifty trick that if you divide like this, then all it does is it will just subtract the volatility, right? And this term cancels out. It's kind of like magic, but it works. Of course, here this W tilde, it's converted to WN, okay, W tilde N. So finally, I just want to mention, right, the connection between this and an interview question that I told you, I guess, a while ago. The interview question was, right, that Black-Scholes formula, right? Everyone going to interview in this kind of jobs definitely must know Black-Scholes formula by heart, that V0 is S0 ND plus minus K eta minus RT ND minus, right? So of course, that's not even a question, right? That's a warm-up question, right? The interviewer will ask you, tell me Black-Scholes formula, and you say blah, blah, blah. And then the interviewer asks, okay, very good. Now tell me the meaning of ND plus and ND minus. Okay? And that's where the real question begins. So you remember what the answers are, or can you rededuce what the answers are?
Okay, so I know that there's like a definition, a formula for like D plus and D minus, and that's basically ND plus and ND minus, just basically computing that under normal distribution.
Is that the answer you're giving?
That's just a guess that I'm trying.
Oh, that's fine. But what you're saying is you're telling how to compute ND plus and ND minus, not the meaning.
I see.
You know what I'm trying to say? For example, right? I mean, when I ask you, for example, the meaning of, I don't know, this, right?
Oh,
you
that.
could tell me, take this and divide them. That's how to compute. But the meaning is this is the price of the stock under the foreign currency, right? That's the meaning.
Yeah.
What's the
Oh, I see. Okay.
You know what I'm trying to say? Like the hue of this, right? So what is it?
I'm not sure. Please.
So a hint, right, is that obviously, Dawn, you kind of refer to this, right, as normal something. So it's some kind of probabilities. You should at least get that much, meaning it's a probability. So the meaning obviously refers to probability of what? Right? The moment you can nail that down, then you answer the question, right? It's a probability. We agree on that. Probability of what event? What event is it a probability of? Are they probability of? Does anyone know? And why, right? Of course, the interviewer would be interested in you explaining why that's the case. Okay, so go back to square one, which is, let's start from the definition, the pricing formula, right? Let's just do this. And then let's rewrite this as this. Then whoops. Yeah. Right. So remember that expectation of an indicator function is a probability. Therefore, right, this term is just probability like that. Okay.
Oh, so basically it's like the probability of ST being greater than K?
Yeah, you can even do better than that, right?
Oh, okay.
Probability of the option expiring in the money. I mean, better than that is not like you're wrong, but being more financially, so that the viewer gets impressed, right?
Okay.
So yes, right. So which term is this, by the way? ND plus, ND minus?
Probably the probability term.
Yes, Don, but like
Mhm.
this one, right? But we have ND plus and ND minus. Which one is it?
I think that one specifically is ND minus.
Yeah, it's ND minus because it's that one right there, right?
Yeah, yeah.
That's ND minus. So there, right? So ND minus is the probability, is the risk neutral probability of expiring in the money. So that's the meaning of ND minus. What about ND plus? ND plus, right, somehow is this term. But you cannot factor out the ST like that, right? Because it's a random variable. But you know that somehow it should be, right, S0 ND plus. Agree? Because that's Black-Scholes formula. So you can deduce this much, that ND plus must be right. Now tell me, can you interpret ND plus now? Well, so this right here, right, it's just an event. You can call it A if you will. If I change this, instead of S, I have N here. Then do you recognize what that is? That's a change of numerator, right? This is exactly that. So of course we have S. So here S is itself playing the role of numerator. So in other words, ND plus is also the probability of the option expiring in the money, but the probability under the choice of S as numerator. So there, even Black-Scholes has a change of numerator hidden in it somewhere, right? So Black-Scholes can be viewed as, using the stock price itself as numerator, okay? And that's that. So these kind of questions, I don't know, do show up, I guess, as an interview question. So it's kind of fun to know that these topics do get asked around, right, in practice. Any question? Okay, so I think it's a good time to take a break. Let's be back here at 10:45, okay? And then we'll try to say a few things about fixed income model, and that'll be it for this semester. All right, so see you at 10:45. All right, so I hope everyone's back. So the very last material of the semester, something about fixed income. So I guess maybe first let's just quickly mention, right, that the final, right, is going to be next Wednesday, right? So let's mention that first. Let's get it out of the way. Final exam next Wednesday. I think same time, right, as a class time. So same format. Of course, you don't get a lecture from me, just exam. So 3 hours. You don't have to use the whole 3 hours. If you finish early, you can just submit and be done with it. Of course, right, there'll be more questions than the midterms because it's final. It's 3 hours. It's going to be cumulative, all right? And I would say that the material should be, all right, should be capped at, change of numeraire. So in other words, I don't think I have time to properly, right, cover fixed income. So I won't put that on the exam, except that, let me say this, right, because students tend to interpret, things very, very strictly. I can still throw in maybe some questions that has the bond topics on it, okay? So bond and, interest rate can still show up, may still show up. Because remember, right, when I discussed the futures price, the forward price, right, that's where they show up. But if they show up, okay, they will show up under the framework that you know how to handle. They will show up under some kind of change of numeraire or just, kind of straightforward somehow, usual pricing or something, right, or apply Vito's formula. Okay, so just because I asked questions that has this names in it doesn't mean that there will be new things. So that's what I mean, right, by saying it's capped at this. All right, like if I throw in these questions, please don't panic and think that I did something unfair. It will still be something that you can, right, handle using, right, your own knowledge. Nothing will be new. The usual way I ask questions, some mathematical questions and some, kind of pseudo coding questions, right? That would be mixed between the two. And that's really it. I will still have office hours on Monday morning. If you have any questions, you want to meet with me at some other time, feel free to let me know. I'll be happy to meet with you to answer any questions. All right. So that is that. Oh, yeah, right. So same format, meaning you will be here at the Zoom meeting. I'm not sure if we have a Zoom meeting for next week setup. If not, I'll send out a link, right? Okay, before. So you can all go to that link and then I'll assign you to your breakout room and you take your exam there. All right.
Sorry, I think you told us the exam is on May 12th. Is it moved up or?
Whoops. May 12th is not Wednesday?
I think it's in 2 weeks. Or
oh, you know what? I lost track of days. You're right. No. I only remember Wednesdays. You see, I'm so excited to give you finals. But this week is really last week already, right? So no, I apologize. But Wednesday is too late, no? I wonder what's the last day of school is. Hold on. So should be May 12th, I think. If I said that, it should be that. Sorry, let me check real quick, okay? Does anyone know when is when are your other exams? Do you know? Let me say Rutgers final schedule. I think if I say May 12, it should be. I just feel like somehow that day is a little bit late. So that's why I thought it's next Wednesday. Hold on. Sorry, give me one moment. Final. May 12th is the last day. Ooh, you know what? Huh, I got 2 exams at the same time. My other class also take exam during that time. That's so weird. I didn't even pay attention. That's fine because the other class there will be just
Oh, May 12th is also on a Wednesday.
yeah. No, I just recognized it's the very last day of class, and I did not know that my other class also take the exam on that same day. Oh, okay, that's fine. I'll just have to handle 2 exams at the same time. That's the magic of online classes. All right, no, May 12th. All right, good. That means I have a lot of grading to do. Okay, fine. Cool. Yeah, you have 2 weeks to study for these materials. Cool. All right, so that's that. Thank you for correcting. I did not even realize that. Any other question? Anyone wants to take the exam early? Anyone wants to take the exam next week? Sherry?
Are we allowed to, or?
That's half a joke. But actually, I do have a preference for, like giving the exam a bit earlier because, the university is very strict on grade submission. And if it's the very last day, that means I have like 40 hours strictly to submit the grade for this class and the other class I teach. So it's desirable for me to get some time to grade. On the other hand, if it's just 1 or 2 people, it may not help that much in that regard. But if you have any reason you want to take the exam early, please let me know before the end of this week so I can prepare. I mean, like, obviously I have to write up the exam, right? If no one takes the exam before next week, then I may not have motivation to write it until next week. You understand? So it's a possibility, right? I'll just leave it open like that. It's a possibility. If you have some compelling reason you want to go to the Bahamas or somewhere, early summer vacation, I understand that. But let me know so I can see if I can work out, writing up the exam early. All right. So.
Okay. Yeah, I would be willing to take it early because I have my COVID shot, the second dose, like the day before.
You're concerned that you won't be, that is even more valid than
Okay.
I would definitely, you know what, my first shot is next week. Wait.
Oh,
Yeah, it's next week. So yeah, we're somewhere along the same line. So sure. But no, I understand that. I think some people definitely have some reaction. So yeah, send me an email. We'll work out something.
okay,
Right.
thank you.
Very good, very good. All right. So any other questions? All right. So last materials of the semester, fixed income modeling. And so I have to say this, right? This is some, big material in and of itself that, cannot be covered, I guess, in 1 hour or so. Even if you give me 3 lectures, right, we may still have something not covered yet. So I just want to give you a broad idea of what's involved, all right? And kind of see how it's similar and also yet different from option pricing, okay? And you can read more in the notes, for example, if you're curious. We also offer an elective course, right, on fixed income. So if you're interested, on that topic, you can take that course, for example. All right, so first, in my opinion, right, first of all, fixed income modeling is about modeling of the bond price. Okay, I have to qualify that, right? This is not only the reason, but bond price seems to be the common thread, okay, of all fixed income modeling. Because, so maybe, let me say this, before I say that, right, let me say this. What process do we model in fixed income? Maybe let me ask that, okay? That's probably the first question you want to pay attention to when you look at fixed income. The reason is this. In option pricing, right? It's quite easy to know what you're modeling. You're modeling the stock, right? Now, recently you see exchange rate and you're like, yeah, why isn't that also modeled? But if you pay attention from some point of view, right, the foreign exchange is also like a stock, right? I mean, it has a special interpretation, but roughly speaking, right, it's still in that class, like it's still a stock, right? It doesn't look that different from a stock. We have to pay attention to it because it, doesn't earn interest rate, that kind of thing, right? But so in that sense, it's like a stock that pays dividend. But ST is model and VT, right, is derived from ST by pricing, right? That's what we mean. That's really, if you want to do option pricing in 2 sentences, that's really it. Model a stock, derive VT from the stock. On the other hand, with fixed income, what do we model? So roughly speaking, right, you might think, okay, RT is modeled. RT is a short rate, right? And then the bond price is derived from RT. That's actually a valid point of view. This is called short rate modeling, okay? Short rate modeling. So, right, I guess the focus, right, is the bond price, for example, right, from, it's like VT is derived from ST, for example. So one point I used to make, I'm not sure if it's a big deal or not, is, when you go to fixed income, right, you may think the bond itself is the product, right, like S. The bond, you might think that the bond plays the role like S. That's not true, right? Because the bond itself is the derived answer from some other things. So the bond, right, is not the underlying, right? Even though we trade bonds, right? It's kind of mysterious that, you see stock more often than option, right? But option is derived from the stock. You see bond more often than interest rate, I guess, in some way, but bond is derived from interest rate, okay? So interest rate itself is like the stock in some way, except, right, the big difference is no one trades interest rate, right? Interest rate is not a tradable product. So mathematically, this is how they are related, okay? But the meaning and the comparison and the taste is very different because of that. So that's the first thing. The second thing is, in option pricing, this is the only way, right? You have stock, you derive the V, right? And that's the only way you can derive the value of the option from the stock itself. In fixed income, there is yet another alternative to model the bond or to derive the bond price. An alternative to fixed income, and it's actually also very popular, is something called the forward rate. I will try to explain the forward rate to you. Okay. But I mean, actually, if you want to see what it is, it's actually quite intuitive. The forward rate is related to the bond price like this. The bond price is related to the forward rate in this way. Okay. So let me write down, okay, the relation between the bond price and the short rate. So it may be a hard question, but for the perceptive among you guys, are these the same? I mean, I guess the intuitive answer is no, right? Because otherwise they're not, we call them different things. But what's the difference, right? This also looks like a discounting factor, right? What's the big deal? I mean, why do we separate the two? What is, where is the difference? And by the way, right, so basically I'm trying to say is, you can model this or you can model this, right? If you model this, then you just get the bond like this. So you can also model the forward rate, right? And then derive the bond price like this. Or you model the short rate and you derive the bond price like this. What's the difference? The difference, right? It may seem trivial, but the difference is whether this expectation is present or not. Okay, that seems like, that's right, not saying anything, anyone can see that this is not present there. But what does that mean? What that means is this, right? That means that this guy right here, right, FTU, all of these guys are present value, right? Present in terms of little t. In other words, all of FTU are known at time little t. All right. So that's why they call forward rate. Forward rate, remember we have a chance to discuss forward price, right? Futures price early on, right, today. So forward, right, is a very, very popular concept in finance. That just means that the ability to lock in something in the future, right? So you can think of this is the ability to lock in a rate that you will start borrowing at time little u in the future. But the lock in, right, you lock it in at time little t. Does that make sense? So the action of borrowing and lending will not happen until time u, but you're locking it in at time little t, right? It's again like, say, I'll tell Sherry that, Sherry, I would like to borrow from you at 1%, but 1 week from now, right? Because we lock in the rate 1% today, right? That's going to be known by today. We sign a contract. But the lock-in, right? The action, I won't start borrowing and selling, paying with Sherry until a week from today, right? So that's the future. Does that make sense? So that's the forward rate. Anyway, right? But when you combine all this forward rate, right, and you add them all up, you really get back to bond price. Okay. So we'll see the mechanics of that in a minute, but I hope intuitively that makes sense, right? On the other hand, right, this is the short rate. So the moment, right, we move away from time t, we don't know what this rate is, right? This is like a floating rate, right? Meaning, the rate tomorrow, the rate after tomorrow, right? That's a random rate. I don't know what they are. So I can still discount them back, but then, right, to translate them to the present, I have to condition on the present information and take expectation. Okay, so that's a big difference. One is like already taking the future into account by being forward looking, right? It's like, this guy right here, right? This is the forward, right? This is a future price of S, right? Meaning that you really, if you, so this is locked in, right? This is locked in at time little t, right? You can call it FSTT. You lock in this price at time little t. At time big T, you pay this to obtain a share of S. Well, of course, there's a future version of this guy too, right? S big T. Right? This is really, you notice this is futures with an S, meaning the product called futures, right? Or because that's confusing, right? Some you just call it forward price. But the ST is really the price in the future of S, right? So you have two actions. One is wait to the future and buy this at this price, which is random, or you can lock in today, right, at time little t, and then in the future pay this much, right? This somehow feels like the same thing in some way, right? Of course, because you're still targeting buying one share of S at time big T, right? That's the action. But one is you lock in the price at the present. One is you wait until the future and pay that floating price, right? Of course, if the market is fair, these two actions should not result in any gap, any arbitrage, right? And that's why we have some relation, right? This class is about kind of studying that kind of relation, right? By risk neutral pricing, etc. That is also reflected here, right? You can lock in the rate and get to, the bond price, or you can just go with a floating rate, right? And then get in that price. Is that okay? So these are two ways, but because, right? So in some way, I kind of did not go into this thing too much, but the point of view is you can model the regular stock price, or you can model its futures price. Okay, we never really play around with modeling the futures price, but we can. So from the fixed income point of view, you can model the short rate, or you can model the forward rate. Okay, they both result in you being able to calculate the bond price, but the taste and the challenge will be quite different. Okay, so do remember those two approaches, right? So short rate model, the famous one will be Vasicek. These are names that you will hear all the time. CIR. Forward rate model. The famous name you will hear is the HJM. Heath, Jarrow, Merton. Merton is a Nobel winner in economics. I think this is Cox, Ingersoll. I have no idea. I think R is Ross. Okay. Anyway, right? These are guys that worked on. I'm not sure there's any gals there, but anyway, right? These are people that have worked on these models. But all right. So first of all, if we have time, right, we will walk through. I will actually at least will mention this model to you today, I hope. But basically studying these models in details and see and compare and contrast in terms of their approach, okay? In modeling the bond price will be one of the target of fixed income modeling. Questions so far? The last one, which is actually not model, but is still a concept, right? So you see, I would like to group this into this, that how to get to a bond price. You can get to a bond price via forward rate, via short rate. There's the last one that actually very popular in practice, but it's not exactly modeled. It's called the yield to maturity. I'm not sure if it's called spot rate, but I like to call it yield to maturity. So yield to maturity is very easy to understand, and actually it probably is the one that's quoted the most. So is this quantity right here, called the yield to maturity, right? And you see, probably some people will call it Y, right? But basically, right, what does it do? This is very easy to understand what it is, right? It basically takes a point of view that if from the point, right, from time little t, right, I look into a future, and if I can use one fixed rate, right, one single fixed rate, and I discount it, right, then that should let me, right, be equal to the bond. Does that make sense? Right, the whole complication of the bond is that, right, the rate will change or the forward rate will change, right? But if I use one single fixed rate, you understand what I mean, right? If it's one single fixed rate, so just to make it easy, right? Suppose I can go back to my original framework, and my wish was, right, the rate is constant, then, right, it's really this. But of course, you see that exactly is, right? Except that, you know, if you are more careful, clearly this guy cannot be the same if little t change and big T change. So that's why you just kind of denote it, right, as dependent on little t and big T. But the idea is still the same, right? It's one single fixed rate that gets you back to the bond, right, in this period. So exactly, right, it's telling you how much yield, right, you're getting during this time of investment, right? So it's called yield to maturity. It's really a function of, right, should be a function of, roughly speaking, right, time to maturity. Except that, you know, if T moves, then this moves too. So that's why we want to reflect this, right? So because, right, the yield to maturity is directly, right, fed into the bond price, conceptually, you can also model the yield to maturity, okay? Right? I mean, that's one third way, right? Besides a short rate and forward rate, you can also model that. Except that, you know, like this feels a bit redundant for several reasons. First is, you know, you quickly realize that because the bond price by definition of the forward rate is this. Because if you know the forward rate, or if you have a way to model the forward rate, then the yield to maturity is just, you know, the average value, right, of the forward rate, really. So what you're saying is, but instead of modeling the forward rate itself, I model its average value. Fine, right? So in fact, I'm not saying that this is exactly redundant because the question is whether you model this or model this. But conventionally, I guess because somehow this guy carries more information or something, so people like to model this, okay, rather than this. So what really happens, right, is that is that we don't model this in practice. Well, practice is, as far as I can tell, right? I don't know if people really model yield to maturity or not, but I haven't seen it as much so far. Is we do not model RTT explicitly, but we impose a desirable structure on it. Okay, so what do I mean by that, right? What I mean is, you know, you look at the yield, right? And by the way, maybe I should take a moment and tell you something about the yield, but we'll get there. The yield is a very popular quote, all right? In fact, I think that website of the, no, that's a short rate anyway, but there's a yield curve, all right, that you can always look up in the you know, Treasury Department website. So you want your yield, right? Because it's such a fundamental object to have some desirable structure. Desirable, just really, a fancy way to say easy to work with. And nothing is easier than something like an affine structure. Affine is just, again, a fancy word for linear plus a constant. So in other words, you're trying to say something like this. Maybe I have a constant term. Again, right, depends on the time, these two time. And then I have this. All right, that's it. You just say that your yield is a combination of these guys, which are called factors. All right. The beauty of this is very flexible, right? Why? Because, unlike stock, right? Unlike stock, well, let me say this, right? I guess in normal condition, the yield should be positive, right? Should be positive. But, I guess that we have seen, right, negative yield before, etc. So these guys have a lot of flexibility on being whatever they want to be. So in fact, you will see their short rate model that can take negative value itself, right? The model allow the possibility that the interest rate can be negative. All right. So anyway, there are great flexibilities in choosing these guys. They are called factors. In other words, if you have taken, I forgot something called Fama French approach in economics. Basically, they break down, right, the market into different factors, right? So these can be viewed or can be linked to that kind of concept. In other words, you can say your yield is influenced by, I don't know, import-export factor, foreign exchange factor. Right? Factor just basically a measurement of how those guys moved, right? So all these can be influencing the yield, all right? So these are called, factor model. So the xi, right, the xit are factors. And so if you have so many factors, you call it the n factor model, right? Where the more factors you have, the more flexible you can model your yield curve. I haven't mentioned the yield curve to you. I will in a little bit. But so you say that you want, right, the yield curve to have such desirable structure. And then you go and say that, okay, let me look for some short rate model that will result in this affine structure, okay? So, and then look for a short rate model that results in this structure. And so let me stop there and let me say that, these popular names like this, where I mentioned them, they will turn out to be factor model. I believe that the Vasicek is a one factor model. Can Vasicek be multi-factor model? I forgot, but let me just say that the Vasicek and CIR, they are affine factor model. In other words, if you apply this short rate model, right, and this is a little bit complicated, right? It's not that simple. That if you apply this model for the R, you plug them into the pricing machinery, somehow it will come out that your yield curve, the bond price has a yield structure that is affine in some stochastic process, okay? Maybe I forgot to mention. So the way you look at this is this, right? These are deterministic functions of little t and big T, all right? These are deterministic functions. All the randomness comes from the factors, okay? All the randomness, all the volatility come from the factors, okay? These are just constant terms. All right. Do I confuse you yet? Does it make sense in some way? Any question? Okay, so if I did not lose you yet, let me tell you about the yield curve. All right, maybe that's more important than none. The yield curve is something that you should always know if you dabble in finance. The yield curve basically, right, is this curve right here. Except that, right, and this is the last peculiarity of fixed income pricing that I want to tell you. In fixed income modeling, you almost always see object with two dependency, little t and big T, all right? This is a phenomenon that we don't see in option pricing, right? In option pricing, you only see little t. There's a big T, right? Implicitly, that's the time to expiration, right? But that's the time of expiration. But we never really carry it, right? We kind of know that it's somewhere there. On the other hand, with fixed income, you always have these two guys listed out. And I think Kashif was asking that when he was asking for forward price, right? Why do we have these two notations or something? The reason is, right, that somehow the dependency on big T, right, the time to expiration is important. And most of the time, sometimes you care, so you care for this and you care for both, right? So if you fix big T and you change little t, what you're looking at is basically the yield of a particular bond, right? As t moves to maturity, right? And typically this move is stochastic, meaning it's fluctuating a lot, right? The yield of the bond. Interesting, but more academic, meaning people know, right, that the yield moves randomly. A lot of times, which may be a little bit surprising, people care for this move, fix little t and move big T. This is the deal. And when people talk about the yield curve, they talk about this. They don't talk about this. So, like that one little thing can trip you up if you don't know which one they're talking about. This one they talk about, right? Why? Because, and this has a name for it, it's called term structure. Okay. And this move, I mean, the move is deterministic and it's smooth. Let me just say deterministic in quote, but it's smooth. So let me even throw that one away. It's definitely stochastic, but let me say this is erratic, volatile. This move is smooth. Okay. So let me tell you what I mean. For example, right? If you have a fixed T, and if you plot RTT, right, it may move like this, and eventually it goes to zero, right? Because as you go to maturity, right? Sorry, so it should go to zero at time big T, right? It will move like this, right? So as time change, so T goes to big T, this happens for RTT. And this, like I said, is not a very interesting thing to track. What people like to track is this, right? And let's just even look at R0, right? At zero, when you look out, you have a 3-month term, 6 month, 1 year, let's say 5 year, right? 10, I guess 20 and 30, I believe. And what are you looking at? You're looking at the yield to maturity at those times. And you tend to see a smooth curve like that. Okay. And that's why I mean like it's smooth. Because what are we saying, right? So this is R0 as a function of T. So what we're saying, right, is this is exactly what you can borrow or lend if you look at 3 months out. This is what you can borrow or lend if you look at 6 months out, right? This is your yield, right? On average. And you see, right, obviously it's increasing because, right, everyone knows that the more you lock in, the longer you lock in your money, right? There's always time value of money, but the longer you lock it in, right, the more on average you must be compensated so that, you know, you can part with your money for that longer period. Yes. So the yield curve always is an increasing function. And again, right, yield curve really means as a function of big T, not small t, right? The yield curve is always a function, increasing function. It concave down like this because, you know, like there's an increasing, right, but it tends to level out, right? I guess there's a sharp change. This is what we expect. This is a typical yield curve, meaning academic, theoretical, right? In real life, right, things don't always happen like this, and sometimes the yield curve can be inverted, right? I don't know exactly how the inversion can happen, but it does happen that, for example, right, that the yield curve can do something like this, right? There's some inversion. So I'm not sure. Okay, I don't want to tell you something that may not be true, but it could be something like this, some kind of inversion, okay? I think recently something like that happened where, very interestingly, you get paid less for parting with your money for longer, and you get paid more for parting with your money shorter, right? So the common name for that is the inversion of the yield curve, right? And what really happens is this, that means that the economy is facing some issue, okay? In other words, right, the yield curve also reflects people's point of view in terms of risk, right? It's not just about time value of money. In this class, we don't factor in risk attitude, right? Because we're risk neutral, remember? We're just risk neutral. But in real life, right, risk plays a role. So I guess, again, right, I'm not an expert on this, but if somehow people worry, like the near future seems more attractive than the far future, then somehow, right, people place a higher premium, okay, on near present borrowing than, you know, in the far future borrowing, right? Which is not what common sense will tell you. But then again, right, that means a risk attitude is changing, and that, right, that reflects something fundamentally is maybe not right in the economy. In fact, right, people say that when an inversion of yield curve happens, that means that we are going to a depression or something. So, right, that the yield curve is watched very closely, right, and as an indicator of the market's health. Anyway, right, from our point of view, you see that when you do these kind of things, you implicitly are saying something about a yield curve, right? Or in other words, one thing that is very, very new, right, in fixed income modeling is that you are not just talking about one single product at a single time. Whether you want to or not, right, you may think that, oh, I'm just pricing the single bond. Not really. This big T is there, right? And you will, right, implicitly or explicitly, here is explicit, right? Here is implicit. Talk about different bonds at different time to maturity, or in some way, there's a yield curve sitting behind, okay, all these bonds that you are modeling, whether you want to or not. So in fixed income, right, when you work in fixed income, right, implicitly or explicitly depends, or explicitly, we price all BTT for different T's, okay? Again, that's not a phenomenon that happens with option pricing, right? With option pricing, you have a fixed big T and that's it, right? There's another fixed big T you look at later. But when you look at bond price, you price all these bonds in some way simultaneously. Okay, you may not do that for this particular problem, but what you do there has a consequence or has an implication on how this yield curve will look, for example. Does that make sense? That's actually a very, very subtle point that, usually after we master, these models, for example, and see how they play out in terms of the bond price, then we start to kind of investigate a little bit on this relation, right? But here, I think it's important enough that I tell you right there that in fixed income, right, this guy is the object that is behind the scene that you want to pay attention to. Any question on this? Okay, so I will tell you the Check model and CIR model very quickly. But even before that, let me just say one more thing. Actually, it's kind of curious too, right? Why somehow, the dependence on big T becomes such a big deal in fixed income, while, the dependence on big T, right, is not a big deal in option pricing. Because, like with option pricing, right, we also have options at different times of maturity, right? So with bond, we also basically have bond with different time of maturity, right? So why is it that with bond somehow this big T becomes such an important, variable, while with the option we don't quite have it? It feels natural, right? It feels natural that I bring up this dependence on time to maturity with the bond. I guess you won't question me on that. But if you want to press a little bit further, what is it that really makes a difference? Because with option pricing, you also have dependence on big T, right? What do you think? So I don't know if there's any reason for this, all right? I mean, you just kind of take it as a matter of fact. Like when you go into, fixed income, you will look at, dependence on big T. Here's my own personal kind of take on this. The reason why, right, with option pricing, even though you have dependence on big T, right, time expiration, right? I guess it's also kind of the clue is also in the way we call it. In terms of option pricing, we call it expiration, right? But with fixed income, you call it time to maturity, right? Do you see a difference, right? Expiration and mature, it sort of carries different meaning, right? I think is this, right? Expiration kind of means you're done, right? Expire, done, nothing to do. Maturity means mature, but there may be life after, I guess. So that's really it, I guess. Again, my personal take is that with fixed income, a very typical thing, which if you're not used to, may cause you to kind of feel a little bit awkward, is rollover, right? Basically, it's very natural for people to, say, starting out, they deposit, right, they're saving for 3 months. But then at 3 months end, right, they like to continue that for a year. And then at 1 year, they like to continue that until 10 years, right? And by the way, in some sense, it is still the same product. Why? Because you're just talking about cash flow of money, right, with time, right? So time value of money. So it's still the same product. On the other hand, right, you don't have the same thing that happens with option, right? So you have an option that expires in 3 months. Okay, boom, at 3 months, that's it. You strike in a strike out, and then you might buy a new option, but that's going to be a very new product, right? That has nothing to do with the old ones right there, right? On the other hand, with rollover, what happens is when you roll over like this, there is some relation with the way you would do things starting from 1 and just looking at 10. If you understand what I'm trying to say, right? Basically with fixed income, right, you may think, right, there's a person who starts saving for 3 months, then a year, and then 10 years. And then there's another person who just starting out saving for the whole 10 years, right? But because underlying, right, their scheme is kind of similar stuff, right? Just cash flow of money. There is a connection between these two. If you want to be a little more specific, there's something here that I'm referring to, which is like the they call the swap, okay, interest rate swap. One person may do this with a, when they do this, I guess they do this with a floating rate, because they at 3 months, right? They have, when they want to renew again, they will have to renew with a rate that's available in 3 months. In a year, if they want to renew again, they have to renew it with, you know, the rate available in that 1 year, right, at that time. So this guy right here do it with floating rate, while the person who does it for the whole duration would probably get a fixed rate, right? Because it's fixed for the whole duration. Now, interest rate swap means that these two guys, you know, swap their rates, right? The fixed guy say, your floating rate looks attractive to me, right? Let me have yours. And the other guy say, cool, yeah, you know, I can have yours. But of course, right, when they swap like this, it's not fair, right? Meaning one guy may have an advantage. How do we decide, you know, what is it that to charge? Or I guess a more usual question to ask is, okay, this guy plays floating rate, we cannot control it. But this guy, right, plays a fixed rate. What kind of fixed rate can we use such that when they swap, they don't have to exchange money? Okay, sounds familiar? That's exactly like a forward contract, right? But except here it's called a swap rate. So what fixed rate, right, can we use so that when they exchange, okay, the fixed rate and the variable rate, they don't have to, you know, exchange money. And if we can figure out that rate, is called a swap rate. And the swap rate argument exactly relies on the phenomenon of rolling over, right? You just roll over, roll over, roll over. So because of that, right, naturally, right, you have to look at different time to maturity in the same product, right, in the same product when in fixed income. But with option, right, once the product expires, its life ends, right? You do not re-look it, you do not look at it again, you know, in the next cycle. Does that make sense? So that's why, right, with option, even though you have different time to maturity, you don't care, right? That time is for that product, another time is for another product. But here, right, even though this looks like different products, these guys have a subtle connection in a way. Okay. All right. So I have 2 minutes to tell you about short rate model. So stay with me, right? I will tell you that real quick because I think you can appreciate this, and that will be the last thing we say for this class. The Vasicek model, one factor model, will be like this. DRT is K mu minus R et plus sigma d dot utility. The CIR model will be almost like the Vasicek, except you have a square root term. Okay. So several things to pay attention to, and maybe I'll let you to play with this in your review session or something, just to get a feel. First of all, these are called, is it called mean return model? Or, God, I forgot the terminology already. But basically, or mean reversion model, meaning that on average, they always return to their average level, which is mu. Okay. So in doing this, it captures this phenomenon of interest rate, that, right, interest rate is not like stock. They don't climb forever. You know, interest rate don't climb forever like that, right? Stock can increase and increase, right? Interest rate from the time of, you know, our grandfather, grandparents up to our time, right? It can be high and low, but it tends to hover around, I guess, 1 to 10%, right? So in other words, there must be something that pull it back to some level. And this mechanism right here is what pulls it back, right? If R is below mu, it goes up because this is positive. If R is above mu, it goes down because it's negative. So this mechanism is present in both models. The Vasey check does not have this term. The effect of this is, right, the moment you touch 0, the Brownian motion can pull you down under the Vasey check model. So the Vasey check model, the RT can be negative. The CIR model, the moment you touch 0, this square root here will turn off your Brownian motion, because the moment you touch 0, this will be 0. So it's beautifully done so that the moment you touch 0, the Brownian motion is turned off, so that because the 0 is less than this, you get pulled up immediately. So with the CRI model, you never have to worry about your interest rate being positive, negative. Now, don't be too quick to say that then this is better than that, because sometimes people like to model interest rate being negative, all right? Second of all, and this will be the absolute last point I'll promise, is that the Vasey check model, you can solve for it. And trust me, you guys can solve it, all right? And this may be a final exam question. Solve for this explicitly, okay? On the other hand, CIR, no, there's no explicit solution because of the square root. So you don't know the solution to CIR analytically. So by definition, CIR must be approached like computationally. Monte Carlo or numerical method. All right. So if you prefer an analytical solution, right, tractability, then Vasey check is your guy. If you don't care for that and you want something that has this robust feature, then you go with CIR. All right. So, well, sorry for keeping you over. Thank you for attending this semester. And if you have any questions, I'll answer. If not, I'll see you in 2 weeks. You can ask me questions anytime from now to then. All right. So thank you guys.
All right. Thank you so much, Professor.
Yeah, thank you, Don.
It was a really good semester. Also, one more question. We won't have any more homework assignments after this, right?
I will post something, right, just to indicate some direction, preparing you for this kind of materials. By the way, right, I don't count this as interest rate questions really, because the way you solve them is really from the previous topics. That's what I mean, right? So I may post something. They're not due, so you don't have to submit them, but you should.
Oh, so it's just like practice problems?
Correct, right? For these topics, right? For these coming up topics, for the same with the review session, right? I might write something, right? So you have some look at that with the TA, right? But yeah.
Okay. All right, got it.
So no more due stuff after this week, but something for you to look at still.
All right, it's definitely helpful. Right, well, once again, thank you very much for this semester, Professor.
Yeah, thank you.
Definitely learned a lot from it.
Oh, I hope so.
Yep.
Thank you, Sherry. Thank you.